Alright, in this video we will look at how to find a node value in a given single linked list. We use traversal to search in a given linked list. The only difference is, here as soon as we find the searched node, we terminate the loop and exit. In the worst case, we might travel from the first node to the last node as we did in traversal. So let's say we have a single linked list like this. So the idea is, if we are looking for the value of 5 in this linked list, so first we are going to start from the first node. So we will visit first node and see that if this node's value is equal to 5 or not. Now in this case we see that this node's value is 1, so we will continue to the next node. So in the next node we have a node in which the value is 2. So one more time we are going to compare 5 with 2. We see that 2 is not equal to 5, so this means that we need to continue to the next node. So in the next step we are going to continue to the next node. So in the next node we have value of 4. So this time this is not also equal to 5, so this means that we are not going to stop over here, we will continue to the next node. So in the next node, when we continue to the next node, we see that the value of 5 is located over here. So when we reach this node, we are going to terminate our traversal and printing out to the console saying that this node is located at this location over here. So if we start to search for a value that does not exist in our linked list, the loop will traverse all nodes and return saying that the value does not exist in this single linked list. So let's see the algorithm of searching a node in a single linked list. So algorithm starts from here. So as a parameter it will take node value. So then the first thing that we are going to do, we are going to check the head value. So if head equals to null, it means that we have not created single linked list. So this means that we are going to terminate our algorithm. Otherwise we are going to continue looping through all nodes over here. So while we are looping through the all nodes, we are going to check that if node value is equal to the current node's value, then in this case we are going to terminate our algorithm and we will print out message saying that this node is located at this location. Otherwise, we are going to go back and loop through all nodes over here. And this will continue until we reach the last node. So if we reach the last node and we see that we couldn't find the value that we are looking for, we are going to print out to the console saying that the value does not exist in this single linked list. So the logic is very simple. So based on this logic, we are going to create our search method in Java. So let's get started. Now here inside this single linked list class, we are going to create a new method which is called search node method. So in this case, this method will return boolean value. So I'm going to put boolean and the method name will be search node. So as a parameter, this method will take integer parameter. So it's going to be node value. So this is the value that we are going to look in our single linked list. So the first thing that we are going to do, we are going to check our head value. So if head is not equal to null, so this means that our linked list exists. So we can do all operation inside this if condition over here. So here, the first thing that I'm going to do, I'm going to create temporal node and setting the head value to this temporal node over here. So it's going to be type of node, which is the node class over here. Then the name will be temp node and it will take the head value, because while we are looping through the loop, we are going to start from the head value. That's why we are putting our head value. Then we are going to loop through the single linked list with the help of size. So as we did over here, we are going to do the same operation over here as well. So what we are going to do, I will create for loop like this. For I starts from 0 and it will continue until the size of this single linked list. And then in each step, it's increased by 1. Then inside this loop, we are going to check the current node's value with the value that we are looking for. So if temp node, which will be the current node, value is equal to the node value that we are looking for, that comes from this parameter over here, then in this case it means that we have found the node in this single linked list. So in this case I'm going to print out to the console saying that found the node at location I. So in this case I will be the location of the node that we are looking for. So I'm going to print out like this, print. So the message will be found the node at location. So here I'm going to concatenate I, then I will put new line character over here. Then after doing so, we are going to return true. So this means that the value exists in our single linked list. So if we couldn't find our node in this current value, then in this case we are going to continue to the next node. So to continue to the next node, we have to set the temp node to the temp node next reference, because in the next reference we are pointing to the next node. So by doing so, we are continuing to the next node. So at the end, if we couldn't find our node after looping through all elements, we are going to print out message to the console saying that node not found. So I'm going to put like this, system out.print, and the message will be node not found. So then after returning the message, we are going to return false. So this means that if our method returns false, it means that the node is not exist in our single linked list. So with this, we have finished our search method. So basically what we are doing over here is we are looping through the all elements of the single linked list, and in each step we are checking that if the current node's value is equal to the node value that we are looking for. In this case, we are returning message saying that node found at this location. Otherwise, we are continuing to the next node. So if we cannot find it, at the end we are returning message saying that node not found. Now let's see how this is working in practice. So what I'm going to do over here is, so we have created our single linked list like this. Then we have inserted some elements to this single linked list. So in this case, we have 1, 2, 3, 4, 5 elements in our single linked list. So before searching for single linked list, I'm going to traverse through the single linked list to show the elements. Then, for example, let's look at for the value of 7 in this case. So if we run our code, you see that first it's printing out our single linked list. Then it says that value of 7 found at the location of 3. If we look at this single linked list over here, we see that at the location of 0, 9, then at the location of 1 we have 5, then at the location of 2 we have 6, and at the location of 3 we have 7. So this means that our method works the way that we want. For example, if I search for the value that does not exist in our single linked list, we will see that it will return a message saying that not found. So you see that the message says that node not found. So our method works the way that we want. Now let's see what's the time and space complexity for this method over here. So as always, we are going to start from the first line of code. So in the first line of code, we are checking that if the head is not equal to none. So this if condition will take a one-time complexity. Then we are continuing to the next line of code. So in the next line of code, we are creating temp node and assigning head value to it. So this line of code also will take a one-time complexity. Then we are continuing to the next line of code. So in the next line of code, we have for loop. So we are looping through all elements of the single linked list. So this means that if the number of elements is n, so the time complexity will be O(n). Because in this case, at the worst case, we are visiting all elements of single linked list. Now then inside this loop, we have if condition like this, in which we are checking the temp value with the value that comes from the parameter and printing out message to the console. So this 3 line of code inside this if condition will take a one-time complexity. Then after if condition, we are continuing to the next node. So here we are assigning temp node's next value to the temp node. So this will take a one-time complexity. Then at the end, if we couldn't find the node, we are printing out message saying that node not found. So this will also take a one-time complexity. Now if we combine all these complexities over here, we get n-time complexity because non-dominant terms will be eliminated over here. Now the space complexity is O1 because in this case an additional memory is not required to search for a node in a single linked list. So that's why space complexity is O1. Now with this, we have come to the end of this lecture. So in this lecture, we have explained how can we search for a node in a single linked list. Basically, we are using linear search. This means that we are visiting each element one by one and comparing node value with the value that we are looking for. If we found, we are printing out message to the console saying that we have found node at this location. Otherwise, we are printing out message to the console saying that node not found. So hopefully everything is clear about how to search for a node in a single linked list. So see you in the next lecture.